Actually, we'll take in the laboratory the crushed ice cubes because it won't take much time to observe the changes. Okay, and so this is the general setup we'll take, children. This is nothing. What do you mean by this? What is this?
Tripod stand.
This is tripod stand. What are the?
That's a thermometer.
That's what you are saying, tripod stand. I did not ask about the tripod stand. I'm just asking you about what is this. This is nothing but a thermometer. Very good. This is nothing but a clamp. Clamp, stand containing clamp or somewhat. Okay, stand, clamp and stand. This is clamp. Yes, this is beaker. Okay, ice cubes. Yes.
Fire gauge.
Bunsen burner. Tripod stand. Is it visible to everyone? Okay. I think I have done a nice presentation to you all so that you can observe it. If it is not, I just explain on the board. Okay, no problem. Doesn't matter. Okay, this thermometer we have taken. We clamped the thermometer and just we inserted the thermometer in the beaker. Just the tip of the, it's nothing but bulb, no? The tip of the thermometer is called as bulb. That bulb should be understood. What happened? That bulb should just touch the tip of the ice cubes. And this is wire gauze, tripod stand, and what is this? Bunsen burner. This is the general setup to study about the melting and boiling point. Okay, so when I have given continuously the heat energy, so immediately starting I observe. So we need to observe continuously the temperature for every minute. For every minute, we need to observe the temperature in the thermometer. Whether the temperature is raising for 1 minute. Okay, for 1 minute, 0 degrees Celsius. For 2 minutes, what did you observe? For 3 minutes, this is the observations you are going to note down while doing the practical. Understood, children? So when I place the thermometer, the temperature is 0 degrees Celsius. Why? Because 0. Sometimes it is below 0. What is this? What is the system? If I don't want the slide, we'll go with the 25. Yes. Okay. Okay, this is the latent heat of fusion. Yes, finally we got it. Okay. Understood, children? So at first, when I insert the thermometer, when I start giving the temperature is for 0 degrees Celsius. Okay, or minus 0 degrees, for some time. After 1 minute, though you are giving continuous heat energy, after 1 minute also, I'll find the same temperature. After 2 minutes also, the temperature is same. After 3 minutes also, the temperature is constant. There is no change in the temperature. But here we are giving temperature continuously. Yes or no? But here we are giving continuously the temperature. The same thermometer, place it in the hot water. Place the vessel containing hot water on the stove and place the thermometer. But we will find instantly the temperature rises. Arnav.
Yep.
So what happened to the temperature? So the time is like when we have taken the graph, temperature and time. Obviously, when you are giving the heat energy, that there should be a change in temperature. Yes or no?
Yes.
But the thermometer is not showing any temperature. The temperature is constant for some time. What happened to this temperature? What happened to this heat energy? Where does it go?
Ma'am, this heat energy is used to convert the ice into water by overcoming
How?
the force of attraction
Yes,
between.
it's not overcoming. We simply say that. Okay, for some time the temperature is constant, and we can see after some time the temperature rises. At this particular this is known as the temperature is undergoing latent heat or fusion. What do you mean by latent? Latent means hidden. Latent means what? Latent heat means hidden temperature. The temperature is hiding. It is not appearing in the thermometer. It is hiding. Where does it hiding? So here, if we have taken the solid, consider this is ice cube. The ice cube consists of particles, ice particles. If they are solids, the particles are very closely attract each other. The force of attraction is more. So this heat energy will go between each particle and it breaks. Then only it converts, no? Yes or no? Bhumika, are you getting? Sahas?
Yes, ma'am.
Yes. Okay. This temperature, this temperature is working on the force of attraction between the particles of ice cubes. So this hidden temperature is what it's going inside the particles. It is breaking the force of attraction of the particles. Then only the particles will lose. They'll go far. Then only they convert. When they completely breaks the force of attraction, then we can see the raising temperature. So fusion is nothing but that the hidden temperature is used to break the force of attraction between the solids at an atmospheric pressure, and it will undergo melting without change in the temperature. Is known as latent heat of fusion. You can read the definition, children. The quantity of heat energy required to change 1 kg of solid into liquid at atmospheric pressure at its melting without any change in temperature. Without change in temperature, in the sense we can't see the raising temperature. Though we are giving continuous heat energy, but we can't see any raising temperature in the thermometer. The temperature is constant, but the work is stopped out there. Is that the work stopped in the beaker? No. The temperature is doing its own work, but the temperature is not raising. It is constant for some time. Because it is melting. How it is melting? By breaking the force of attraction between the particles in the ice cubes. Between the ice cube particles.
Yes, ma'am.
Understood?
Yes, ma'am.
Alifia, na? Alifia? Are you there? So here we can see the graphical representation of this heat energy, temperature and time. Temperature and time. You can see the graphical representation. This is temperature and this is time. We can see the temperature is 0 and gradually like minus and gradually it goes to 0 and constant for some time. And it raises. Why it is raising? Because raising in the sense it is attaining its melting point, it raises. Obviously, that means it converting. And again, after some time, again we can see that temperature is constant for some time. Why? Why?
Latent heat of vaporization.
Yes. So here, when you are giving increasing temperature, you are continuously giving temperature, no? You are continuously giving temperature. You are not stopping the Bunsen burner. You are not stopping, no? You are not stopping the burner. That means you are continuously giving. So definitely, the solid converts to liquid. What is the next state? What is the next state, children? The next state is gas. Liquid to gas. Solid to liquid. Oh, okay, I erased it. Solid to liquid. For some time, the temperature is constant. That constant temperature is known as latent heat of fusion. What do you mean by latent heat of fusion? That a hidden temperature is used to break the force of attraction so that the solid melts. The solid melts. When we are in, when we are like united, so whatever we'll do the teamwork, so it will be successful. Yes or no? When we do the teamwork, because the bonding, the understanding between the friends are strong, so definitely the teamwork will proves we are going to face the success. Definitely. But when we are divided, what happened? If we are strong enough, okay. But when we do the teamwork, the work level also reduces. So many ideas we'll share our views. So we learn from one friend to the other friend. Okay, definitely strongness will be there. When they divided, what happened? What happened? That much strong, their thoughts won't be. Yes or no, children? Are you getting? The same way, the solid particles are very much strong. So it will take time to break the force of attraction between the particles. That's why the temperature is not appeared in the thermometer. It will hide. Latent means hide. Heat means temperature, hidden temperature. Fusion means converting to solid to liquid. This is known as latent heat of fusion. Any doubts? Yeah? When the temperature raises up to some extent, and again we can see for some time the temperature again is constant. What happened to this temperature? Again, this temperature is working on liquid particles. It will break the force of attraction between the liquid particles. When it works on the force of attraction between the liquid particles, so that the liquid converts to gas. This is known as latent heat of vaporization. This is known as latent heat of vaporization. Understood? The quantity of heat energy required to change 1 kg of liquid into vapor at atmospheric pressure at its boiling point without any change in temperature is called latent heat of vaporization. Any doubts? Any doubts? So here we can see solid to liquid, liquid to gas. The above arrow mark, no ma'am in the sense? Bhumika, no means no doubts?
Yes, ma'am, no doubts, ma'am.
Okay, good. Good. If you have the doubt also, it's good. Ask, no problem. I'll give time to clarify your doubts in the concept. Okay? Okay, solid converts to liquid, liquid converts to gas. This arrow mark shows the direction, and this arrow mark, the above arrow mark is nothing but increase in temperature. Below arrow mark shows decrease in temperature. Understood? Liquid to state means freezing. Gas to liquid means condensation. Solid to liquid means melting. Yes? Liquid to gas means evaporating or vaporizing. Understood, children?
Yes.
The SI units of latent heat of fusion and vaporization, joules kg inverse. Joules kg inverse. Or joules by kg. Understood, children? Here in this chapter, no need to solve any problems or problematic questions are not arised in this chapter. But at the last, there is a concept for conversion of degree Celsius to Kelvin, Kelvin to degree Celsius. That is at the last of this chapter. So this is the main concept. One more concept is there, evaporation. That is my graded to few concepts are there, so that we can complete this. Okay, this latent heat of vaporization is nothing but, so this conversion of liquid to gas. Conversion of liquid to gas. Understood? What we called as conversion of liquid to gas? Vaporization. Okay, for some time, the temperature is constant. Where does this temperature goes? This temperature is used to break the force of attraction between the particles of liquid. Understood, children? Any doubts?